right on time here. So welcome, my name's Adam Culp. I'm going to be talking about does your code measure up? How many PHP developers do we have? Yeah, good, most everybody? Okay, cool. So again, my name's Adam Culp. You can find me on Twitter at Adam Culp, just my first name, last name. I'm easy to find. I asked that please, after I get done talking, please go out to Joined In and rate the talk. This is talk number 13943, so please go out and rate it. I talk a lot at conferences, so I do about 10 to 13 conferences a year. I speak quite a bit, so I appreciate any feedback I can get to help me tweak the talk for future audiences of talks, because I generally give them more than once. So please go out and leave me feedback after I'm finished. A little bit about me. I'm a PHP 5.3 certified engineer. I work for Zen Technologies as a consultant, so oftentimes I'm going out to companies and talking about just this topic, as well as refactoring. I'm generally helping companies tweak their code to make it better performing, tweaking it to make the code quality better, also doing some refactoring or helping companies create good architecture from the beginning on brand new applications. And that's a lot of what I do. So if any of you need help with that or anything else, just let me know. I'm an organizer of South Florida PHP user group. We're located in Florida from West Palm Beach all the way down to Miami. I have about 750 members in the user group. And I'm also the organizer of Sunshine PHP. It's a conference. We have about 350 attendees in Miami in February, because there's a lot of worse places you can be in February than Miami. So yeah, it's a good time for it to be in Miami for sure. I'm also a long distance ultra runner. For those of you who don't know what that is, marathon is 26.2 miles. Ultra means more than. So I run more than 26.2 mile races. And I'm also a black belt judo instructor. So that's enough about me. One thing you might notice though is I'm a huge fan of iteration. Most everything I do requires iteration of one form or another. Most everything we do in life, to do something well, it requires iteration to get good at it. Like developing, long distance running, for instance. I didn't just jump off the couch one day and say, hey, I'm going to go run 100 miles. You know, it takes practice to get there. It takes a lot of learning to know the nutrition and everything behind that. We all know that martial arts is a lifelong study to master it. I'm very far from that. Development, same thing. We develop over time. We develop iteratively to make our code better, to improve the quality of the code and the quality of how the application works. Evading project managers, that's iterative. We get better at it over time. As well as code quality. We should measure our code quality iteratively to constantly make sure that we're improving the quality of our code. So why measure our code? We measure our code for a lot of different reasons, such as highlighting bugs, to see if bugs jump out in the code. That can be automated in many ways, and we're going to cover some of that throughout the talk. It also helps us improve quality. It makes it easier to onboard new developers, because by improving the quality of our code, improving the architecture and everything, it makes it easier to onboard new people. Also, it means less reading. We as developers spend a large percentage of our time reading code. We spend very little of our time comparatively actually creating new code and enhancing the code. Most of our time is spent reading. You can't add new code if you haven't read what's already there and know how to work with it, right? So we spend a lot of time reading code. We are all authors. All of our code, every line of code that we write is just like writing a book, and for somebody else who's following behind us, and they're going to be reading our code. It also helps improve the testability of the code through improving the quality. And I'm going to cover some key areas why or how that can be made better as well. It also helps us end up with satisfied customers. Obviously, if a customer is waiting on a new feature in an application, and through code quality we're able to create code faster because it's more readable and more easy to understand and maybe a little bit less coupled, our customers are going to be much happier because we're going to be pushing out features much more quickly. Also, there's less broken parts of the application because the code has been made more stable, through this. Also, there's a little bit of personal pride in there. We all like to take a little bit more personal pride in what we do, right? Oftentimes when I'm writing code, I know I want to feel good about what I'm doing. If we don't feel good about what we're doing, we're not going to be happy in our job. and we're going to end up going somewhere else or staying where we are and just being unhappy. But it comes down to a little bit of personal pride. So measuring the code and improving the code quality helps us have a little bit more personal pride in the code. And that can translate into higher salaries. Obviously, if we're able to create better code, we're now able to command a little bit higher salary. Now, that's not always a key thing, I realize. I mean, salary is not a big thing for me. As long as I'm able to make a living, I'm pretty happy with what I do. But it does have a bearing, right? So how do we measure code? That's why we measure code, but how do we measure code? Chances are, if you're measuring code with the WTF meter, it's not really productive, right? You know, if it's based on the amount of feedback coming from people, chances are, you know, you're not doing it really well. So what we want to do is we want to come up with ways to measure the code that is more accurate, more quantifiable, and hopefully automated in some fashion, so that way we're spending less time chasing these things and more time actually producing good code. So some key things that we want to measure is cyclomatic complexity. Everybody know what cyclomatic complexity is? Who doesn't? And it's okay to raise your hand. Cyclomatic complexity, according to Wikipedia, is the count of number of linear independent paths through the source code. So that's basically it's the number of decision points inside the source code. Now, as a general rule, we try to keep cyclomatic complexity less than 10. I personally aim for 6 or less. Now, what does that mean? Cyclomatic complexity, if we look at code, for instance, we look at this function here, we see there's an if statement, then there's a second if statement, and then we're returning, right? Well, that would translate into 1, 2 would be our cyclomatic complexity of that method. So we want to try to keep that cyclomatic complexity low. A method, by definition, should really only do one thing. How many different decision points do you really need to do one thing? So we want to keep it nice and small. A little bit more on that later, but anyway, cyclomatic complexity is one of the things that we want to measure inside of our code base, and that can give us an indication as to the complexity of our code. Another measurement would be duplicate code, right? How many times are we copying and pasting things from one place to another? There's a thing out there called rule of 3. Martin Fowler coined the term rule of 3. Actually, I don't know if it was him or a gang of 4, but somebody during that era, right, from that group of developers. The rule of 3. If you copy and paste something one time, that's not so bad. You just copied and pasted it one time. If you did it a second time, though, copied and pasted a second time, then you kind of wince a little bit, but you still end up doing it. But when you actually copied and pasted something for the third time, it's time to clean it up. It's time to do some refactoring, normalize it a little bit, and that's called the rule of 3. And as a practical example here, we basically have 2 functions, exactly the same function, but a different name, right? But it is pretty much a copy and paste of code. Now, this is an extreme example, but in our code base, oftentimes we copy from one place and paste into another to make functionality work. Again, there's nothing wrong with doing that, as long as you don't overdo it. Okay, you want to try to keep copy-paste down to a minimum, and because you want more stability. Now, if I had this function and I copied and pasted it multiple places throughout my application, well, what happens when this condition changes, right? What happens if there's more values that need to be tested for? Now I have to find every place I copied and pasted that and go fix it everywhere, right? So that's why we don't want to copy-paste too much. But it's inevitable that you're going to have some. Again, just follow the rule of 3 or something like that, and it'll help you a little bit. Another thing that's a key metric to measure is long classes. So a class, I already talked about methods a little bit. I'm going to talk about them a little bit more. But a class is meant to really solve one problem. It's not meant to do one thing. It's meant to solve one problem. So we name our classes according to things like user or product or something like that. I hope you get the gist of it just from that. But our class solves one problem. Generally, we try to keep our classes less than 1,000 lines in length, right? Anything less than that is considered to be okay. Anything above 1,000 lines, chances are your class is trying to solve more than one problem. So you might need to break it out a little bit. So keep in mind that a class is meant to solve one problem. So if a class is very long, longer than 1,000 lines, there may be some issue there. So that's why we measure that. And then we go a step further and we say, well, not only the length of the class, but what about the complexity of the class? Well, as we said before, if we keep our functions the cyclomatic complexity, we want to try to keep those nice and low. So if you have 1,000 lines in your class, obviously you can't have too high of a cyclomatic complexity there, right? Otherwise, you have chances are you have too high of a cyclomatic complexity in your methods as well. So we try to keep our class complexity less than 50, so that way we can kind of gauge how much is our class doing. And we talked a little bit about methods already, but again, methods, we try to keep our methods, as far as the length of method, we try to keep our methods less than 100 lines in length. I personally aim for functions, because a function isn't method, it's just an interchangeable name. I try to personally keep 20 lines or less. That doesn't mean I do that every single time. Again, it's just a benchmark. It's just my personal benchmark. I believe that if I have a method, a function, and it's doing one thing, how many lines of code do you need to do one thing, right? And if we're keeping our methods very dry, meaning don't repeat yourself, DRY, then it's very easy to see where our methods could be very short in doing one single thing. And so we try to go for 100 lines or less. And again, my personal goal, usually I try to go for 20. and a method doing one thing, not more than one thing. Another measurement is unused variables. If we have variables, we're creating temporary variables or creating any other variables in our code and it's not being used anywhere. Obviously, it's just dead weight, right? It's not a bug per se. It's not going to cause your code to have a problem. It's not going to cause any errors. It's just a matter of keeping your code clean. If you have a variable there and somebody following behind you and reading your code, they're like, well, wait a minute, I see this variable here, but I don't see where it's being used. Then how much time do they spend looking to see where that variable was used, right? So again, it's just about readability of the code. It's about keeping the quality high. So those following behind us and reading our code are going to have a little bit easier time. Another thing to measure would be lack or overuse of comments. So please don't take this as me saying don't put comments in your code. Don't always put comments in your code, all right? But if you're adding comments in your code to explain bad code, of course that's not a good thing. We want to put comments that are meaningful, concise, straight to the point, but not necessarily explaining the code. Developers following behind us, they're already developers. They know how to read the code. You don't have to explain the code to them if your code's written well enough, right? They're going to be able to look at it and say, oh yeah, it's supposed to do that. They don't need to read a comment to tell them what it's going to do. Comments should be a little bit more explanatory than that, like maybe why did business decide that bit of business logic needed to happen that way or something like that. I mean, as an example, if we have a comment here, for instance, we have an if statement that's doing a check for us. And actually, there's a typo. This should actually be equals, not double ampersand. So here we have a comment saying, check to see if the employee is eligible for full-time benefits. We're checking to see if there's an hourly flag, and we're also checking to see if the employee age is larger than 65. Now, compare that to code that is more cleaned up, more optimal, right? Where we're creating a method called is eligible for full-time benefits, and we're passing it the ID. All right, do I really need much of a comment to explain what's going on there? Not much at all, because the method name already tells me what it's doing. I don't need to put a comment there. Now again, I'm not saying don't comment your code. I'm just saying we could write our code a little bit more see-through. I do not believe that code can be self-documenting. That's a BS story somebody created somewhere throughout history. Don't believe that. Code cannot be completely self-documenting. But like you see here, we can create method names that make it easier to understand the code, right? It's not self-documenting. We still need a comment on this function saying what the function's doing, like a doc block or something like that. In PHP, we use doc blocks so that way our IDEs can tell us, what's going to be happening in that method without us having to go to the method, and things like that. But for the most part, we don't really need many comments for that. More things to measure. Heavy global usage. First off, if you're using globals, please stop. Don't use globals in your code. But there are many methods of globals, right? We might be using the global keyword. You should not be doing that anytime. Don't do that. But it is available. We could create our own super global, so to speak, and cram stuff into it. Again, try to stay away from that. Or maybe we're using the super globals. I would say in your code, hopefully, if you're developing enterprise level applications, if you're truly being a professional while you're coding, you should not be addressing super globals directly. That should be handled in a framework somewhere, something like that. You should not be using those directly in the code exactly. You should be using them after they've been cleaned or something, through some sort of framework. I'm not going to delve too much into that, but we want to measure global usage in our application to kind of give us some insight. This will tell us in a really quick snapshot of how stable is the code, right? If you have a lot of global usage, the code is not very stable, because if I have this data being called with the global keyword, where was that set? Where was that set in my code if I'm calling it globally in my entire stack, right? We now have to search through the entire code base to find out where all the instances of data exist so that we can find where it was actually set, right? So that's where globals become very bad, and that's why it makes code unstable. Another measurement is end path complexity. This one trips up a lot of people, end path complexity. It's not cyclomatic complexity. Cyclomatic complexity is the number of decision points in the code, right? End path complexity is the number of paths through the code. It's the number of possible outcomes of a function, right? That's end path complexity. We try to keep that less than 200 for a method and keep it nice and simple that way. So as an example, we can see here we have an array, and then inside of our function we're doing a for each, and then we're returning baz, right? What would the end path complexity of that be? Anybody? 3. Yep, 3. Because this array has 3 possible arguments or 3 possible influences on this for each, right? So our end path complexity, in this case, if we took it literally for the array, would be a 3. Now, end path complexity is actually calculated much different than that. I just use this as a very loose example, okay? Because obviously we could return an array of data from our database, loop over it. It could be millions of times. That doesn't necessarily mean our end path complexity is a million. But again, this is just a real rough example. The idea is to keep our end path complexity at least 200 or less. And believe me, it can be very easy to see that number get up to the trillions in some cases. I've seen some folks use something like an exchange array in an entity and doing exchanges and things like that in their entities and end up in the trillions within a method. So it's very easy to get the complexity this high. Now, does this cause your code to run slow? No. But think about it this way. If I have 3 possible outcomes to this method, how many tests do I need for that method? 3. If I have an exchange array that has 1 trillion possible outcomes, how many tests do I have to have for that? Exactly. So the idea is to try to keep the end path complexity lower, therefore we need less tests for that. Now sometimes we really need an end path complexity to be somewhat high. Again, try not to go above 200, but that's the case. Did you have a question?
Yeah, less than 200 paths per project or per class? Or
per method.
Per method.
Yeah, per method. Yeah, that's per method. I should put that on that slide, but I did say per method. No worries. So now, and there's many, many more. There's a lot more different things. We call these code smells. Okay, there's a lot of different code smells. Everybody heard of code smells? Who has not? Feel free to raise your hand. It's fine. So code smells are possible indicators of spoilage, right? So it kind of makes sense. If these things are code smells, now all these things that I highlighted, all these things that we need to measure inside of our code, they are not bad code. Okay, it doesn't mean that if I have, a higher cyclomatic complexity or a higher end path complexity, that does not mean, does not mean the code is bad. It's a smell that indicates there might be spoilage somewhere that we need to pay attention to. So that's why we look for these possible code smells, is to kind of tell us where something might be. You know, if you have a spoiled steak and it's sitting on a plate on the table, but you can smell it clear over here, the smell is not the spoilage. The meat on the plate is spoiled, right? The smell is just telling me, oh, wait, there's something nearby that's spoiled. And that's what code smells are. Code smells are not bad. They just indicate there might be something bad nearby. So again, that's how that works. Now, there's some additional smells that we can look for, like long parameter lists. You know, well, if you have a function, and that function is doing one thing, how many arguments do you really need to pass into that function to do one thing, right? So we want to try to keep our parameter list very short inside going into our functions. If you need multiple data points in order to do one thing, then you would pass in an object or something like that. Use a factory, you know, pass in a factory, and then you're all nice and good. But you keep your arguments nice and you know, minimal, so that way it makes the code easier to follow and easier to go through. Switch statements is another possible code smell. Again, switch statements aren't bad. It's just a smell. Chances are, many times when I look at switch statements inside code, I often find that maybe they're sacrificing polymorphism and some other good practices that can make the code easier to read and follow the execution a lot better. I use switch statements all the time, but it is a code smell that maybe there's better ways to do things in some cases. Not always, some cases. Temporary fields, temporary variables. We define a variable, assign some stuff to it, and then use it later on down inside of our code base. That is a code smell as well. Doesn't mean it's bad. It just means that maybe there's a cleaner way to do that. Maybe not. Maybe a temporary variable is the way to do that, and that's perfectly fine, but it is a code smell. So how do we find these things, right? We've spent some time now talking about all these different code smells, these different things that are inside of our code. How do we find them? There's a site out there called phpqatools.org. At phpqatools.org, it's just a collection. Now, the people who created this site did not create all these tools. They just created this site to put all the tools together nicely for you. So there's just links going to each of them. And there's some documentation there on how to use them as well. But PHP QA Tools is a nice place where you can go and see different tools that are specific to PHP, but help us write better code and help us measure the code. One of those tools is PHP Lock. PHP Lock is PHP lines of code, LOC, lines of code. So PHP Lock. How we execute PHP Lock is via command line. So we call PHP. In this case, I put PHP Lock in a FAR file, and I'm executing it as a FAR. You could download the application and just execute the PHP lock.php and do it that way. But I like using a FAR file for these types of things. It's easier to kick off via command line. I'm passing it the flag of a single V. That's the verbosity, right? So I'm telling it be verbose in the output. I'm passing it the names of the files. In this case, I'm doing asterisk.php. So therefore, I know that it's going to be doing all the PHP files. It's not going to be measuring JavaScript. It's not going to be measuring HTML. I only want it to measure PHP. I will only want the lines of code in PHP files. If you wanted additional files, like maybe a twig file, maybe a CTP in the case of a cake template file, or PHTML, something like that, then you could include that here, in the names. You can tell it to exclude certain directories. Everybody using Composer? How many people are not using Composer? Shame on you.
Well,
You use Composer.
PHP.
What's that? Well, then that's a good example. That's a good reason not to. Shame on you anyway. But no, if you're using PHP, you should be using Composer to bring in dependencies and things like that. I realize there's some legacy applications you might not be able to do that, but Composer is just awesome for pulling in dependencies. In this case, Composer creates a vendor directory and dumps all that third-party code in the vendor directory. So that way it's managed by Composer. You don't have to manage it. I don't want to have to manage somebody else's code, so just put it in the vendor directory. I'm never going to look at it. I'm just going to use it, right? Because hopefully they're doing their own everything else, measuring their complexity and everything else. I do check them out prior to using them, but once I've done that, then I don't want to mess with it ever again. I have my own code to manage. So I'm excluding the vendor directory. I don't need to know the lines of code of the vendor directory because it's not my code. It's somebody else's code. I don't need to count that. In this case, I'm telling it the path to the project, and then I'm telling it the output. I'm piping the output to a PHP Lock.txt, piping the output to that. Now, there are other programming languages too, like you said. They have this same tool. I don't know where they are for your chosen language or whatever, but there are tools out like this for every language. So this is transferable, although the command might be different. So the output of this inside a code base would look something like this. You don't have to be distracted with the output here, and if you want to, you can download the slides. When you go rate this talk, there is a link to the slides already there for you on Joined In, so you can download the slides and look at it to your heart's content. But basically, it's telling me the number of directories, the files in there. It's telling me the lines of code, the lines of comments to go with that code. And then it's telling me how many lines are within classes, how many lines are not within classes, so that indicates there's some procedural code. And in this case, we can see that inside classes, we got 33,000 lines, but we got 139,000 lines of code. So there might be 100,000 lines of procedural code within this code base, right? And it goes on down. I mean, we can look at the number of global accesses. We're using globals here 140 times throughout this code base. And we can see the number of namespaces and everything else. Again, the details aren't as important as just having this snapshot. A lot of times, when people call me out and they say, tell me, can you look at my code and tell me what I've got here? Which happens oftentimes. Business people have no idea what they have, right? They have no idea. Maybe they hired developers, they offshored it or outsourced it. The developers finish up. The business doesn't know what they have. They're business people. They're not developers. So they call somebody out and they say, can you analyze my code and tell me what I have? The first thing I do is I run this. I say, okay, here's what you have. This can very quickly highlight potential problems. Because I can see maybe they use globals too much. Maybe they have a lot of procedural code, and if you have an application where you want to try to keep it dry, procedural code is not very good for that. Maybe this carries the cyclomatic complexity, the average per lines of code, and the average number per method. So I can see all this in a snapshot straight from this tool. And this only takes a few seconds to run on a code base of 500,000 lines or less. It doesn't take a long time to get this information at all. It churns through it really quick. Another automated tool is PHP Depend. And as you would expect with the name like depend, it's looking for dependencies inside the code, right? So again, it's command line as well. I created a FAR file, so it's calling it in a FAR. We're ignoring the vendor directory. We're outputting XML. And I'm also outputting a chart for dependencies, and I'm doing an overview pyramid here as well. So I'm doing a lot with this one command and getting some good snapshot views based on where I have dependencies in my code. Now again, dependencies might be where there's extensions, where maybe we're extending the code instead of using some sort of we're using inheritance instead of composition, things like that. In most modern applications, composition is preferred over inheritance. So this is going to highlight that. The charts that it's output is going to be something like this, right? Where we have the perfect line, being the green between instability and abstraction. So this will kind of lay out all of our objects and tell us where they fall, right? And if everything is down here, it's not going to be very abstract and it's not going to be very stable. Whereas if it's up here, then it's probably pretty good. It might be extreme though. I mean, you can go the extreme the other way. And then of course, then you have a less stable application that way as well. So you want to try to say somewhere in the middle in there. And then of course there's the pyramid that kind of breaks down our lines of code per methods and things like that. You can find, there's a very detailed explanation of what these charts actually provide at pdepend.org. I'm not going to go into all the details of it. We would be here the rest of the day. But please, I mean, if you're interested, go to pdepend.org. These charts give you a good snapshot, and there's a lot of details in these little charts. A lot of good details. One of the other tools is CopyPaste Detector, because of course we want to know how many times something was copied and pasted, right? This tool takes a little bit longer to run because it looks at every single line in the code. It takes a portion of your code base and searches through the whole code base to see if it exists somewhere else. And it does that for the entire code base. So it can take a little while for this to run, especially if you have a large application. I've ran this on applications that are 4 million lines long. And so that can be quite lengthy. You just kind of kick it off at night and go to bed, wake up in the morning, and maybe it's done. But the output is awesome. Again, it's a command line, pretty simple. We're telling it what place to exclude. We're telling it what file to output. Now, the contents of the file that it outputs is pretty decent. I mean, it's going to tell you how many exact clones it found within however many lines of code, and how many files contain these copied and pasted items. And then it's going to be a very lengthy file. This is just a small little extract of that, but it's going to tell you this line matched this line, and it's going to tell you the line number in the file and everything else of exactly where to find those clones. And then at the end, it's going to give you a percentage of your duplication within the application, and it's going to tell you how many lines, and then of course tell you how long it took to run. So this is a priceless tool, because now you know exactly where your copies and pastes are. You don't have to go searching through the application and try to find it yourself. It does all this automatic for you and outputs it into a nice, neat file, and you just start working your way through it. PHP Mess Detector is my most favorite tool. This one is amazing. There are with PHP Mess Detector, there's multiple types of reports to generate with it. I only run 2. The other ones I don't think carry as much value as these 2. One is code size. So, excuse me. So the code size is going to go through, and it's going to tell me the size of so many metrics within my code. Excuse me. It's going to tell me long classes, long methods. It's going to tell me cyclomatic complexity. It's going to tell me NPath complexity, anything related to the size of the code, right? It's going to measure all that. This one does take a little while to run. And then here I'm having it output the file to XML. Notice how there's a little XML here. You can do XML text. You can do, there's a few different outputs. I think XML and text are the only ones that are really usable. The other ones aren't really so great. But I usually put it out as XML because then it's easy to read. I can go through it and read it, or I can parse it if I wanted to with some other tool to better help me go through it. But basically, it's going to have, now what you don't see here is maybe up here at the top, there would actually be a file container, and it would tell you the file. And then here are multiple results based on that file, right? So you have a file container, then what it found, then another file container and what it found, and so on down the line. And you can see things like excessive class length. This class is 1,030 lines. We're looking for 1,000, so it's going to tell us, this is 30 lines longer than we would like it to be. That's probably not a problem here. It's very close, right? It might not be an issue, but at least we know that. We can look at too many methods. So we have 13 methods. We're looking for 10. Cyclomatic complexity of 24 in this method in the dashboard action, and we're looking for 10. So chances are that cyclomatic complexity, that's pretty high. I would probably look at that. But this tells us all the things related to code size, so that way we know where we might have some issues. This report is infinitely usable. This is the one I spend the most time on. The lines of code gives me a snapshot. This gives the details to back it all up. Another useful PHP Mess Detector to use is unused. And what this is going to do is this is going to tell me all the unused code in my application. It's going to tell me unused variables, unused methods. If there's a method or even a class in my code base that's not used anywhere else in the code base, obviously it's just dead weight. I don't need it in my code base. It's just confusing the application. Or more to the point, it's confusing the developers because now they have to look over that code because it's not used anywhere, right? So why even have it? So this is going to highlight those areas. Another useful tool is PHP Dead Code Detector. So PHP Dead Code Detector is going to look for code that's no longer used. Maybe it was used somewhere, but now it's not used anymore. That's kind of the same as the unused. It's kind of a redundant test, but it's good to have it. Now, kind of away from these are the PHP QA tools that I use most often. Now, I'm not including in here PHP Unit. PHP Unit is obviously a very usable tool. But again, this is not about unit testing. This is more about testing your code quality. Although PHP unit does measure your code quality by your tests passing or failing. But what's that? And crap, yeah. But we're not going to dig into that right now. I'm more on the metrics side of it. There's a tool out there called PHP Metrics. And you can find this at phpmetrics.org. This script goes through and does pretty much everything all the PHP QA Tools does and represents it in a little different manner, but it's pretty much the same tests. So you can pull it down with wget, and then you kick it off, and then you use it by issuing PHP metrics, and you tell it where to find where to output the file. And then what you end up with is a nice HTML page with a lot of CSS, and it basically outputs all your results. It's going to give you a maintainability graph that's going to give you the cyclomatic complexity, based on the size of the circles of each of the objects inside your code base. There's other tabs inside this interface that'll tell you the dependencies and everything else. It's a pretty good tool. I use this as a sanity check on the PHP QA Tools items. So I generally run those, and then I'll run this because sometimes this might highlight something that I didn't notice in the long XML forms. Sometimes vice versa. It's good to have a second. It's good to have a second opinion, right? And that's what this tool does. Is it gives me a second opinion, and the output is only a single HTML file. That's all there is to it. You open up the HTML file in your browser, and that is everything right there. All those reports are just in one HTML file, and it takes a little while for the report to run, but it doesn't take long for it to load in the browser, and it's very, very usable. We also have PHP Code Sniffer. Anybody heard of PHP Code Sniffer? Yeah? Everybody using it? So PHP Code Sniffer, it sniffs your code. Obviously, if we have certain things inside of our code that are smells, it makes sense to sniff for them, right? So that's what PHP Code Sniffer does, is it sniffs for these code smells. And the way that it works is you give it rule sets called sniffs, and then you tell it where your code base is and run that sniff on this code base, and it runs the sniff and basically gives you the feedback of here's what I found that matches those sniffs. Oftentimes, this is either done via command line. Most modern IDEs also include a way to use PHP Code Sniffer from within your IDE. So that way it sniffs, you can have it sniff the code interactively while you're creating it. I find that a little bit distractive myself. I don't want to know my code is bad while I'm writing bad code. I want to know it's bad after I finish cleaning it up and everything, right? I don't need all those errors real time. So generally what I'll do is I'll kick it off from my IDE at certain intervals. When I feel that I'm done, now tell me what I found. One of the most valuable ones is I'll have it run inside the IDE to tell me if I'm PSR compliant, Framework Interoperability Group. So that way I know my coding standard is according to what most PHP packages are built with these days. And it's really usable for that. You can also include it in your source control through source control hooks. So whether you're using Subversion or Git or whatever the version control is you're using, you can have your version control run Code Sniffer as a commit hook. So when your developers on your team or you commit code to the repository or attempt to, you can have it run Code Sniffer, and if Code Sniffer fails for one reason or another, it will not commit the code. And it'll tell the developer or you that, sorry, you can't commit the code, you need to fix this first, right? And it's a really good sanity check. It can be a pain to do that. Oftentimes I curse at myself for doing it, but I'm thankful. I thank me later because then I make sure I have good clean code that I'm committing to the repository ahead of time. So, and I'll do things like I'll run the PHP Lock and make sure certain metrics are within a certain boundary. I'll make sure I run the Mess Detector code size and make sure that my methods aren't too long. I don't have too many arguments. I don't have, those things. And if any of those are exceeded, then I can't commit code to my own repository. It just makes sense. I want to make sure I'm doing clean code from the beginning. Oftentimes when I'm coding, I'm never going to be touching that code again. Somebody's going to be following behind me and touching that code. So I don't want them to have crap. I don't want them to talk about me. But at the same time, I don't want them to have to weed through crap to figure out what I did. So I use PHP Mess Detector to sniff it and make sure that I did a pretty good job with the code. You may have noticed if you're using Git on GitHub and using some different open source packages, you may have noticed that there's some other tools that people are using, because now you can create those little chiclets and put them in your README file and have those output on GitHub so you can see whether the code base is decent quality or not. One of the tools used for that is Code Climate. Code Climate is a really good tool for doing a lot of these tools that I've already covered, but they do it on your behalf, right? And they'll do it based on your code base. So as you commit things to GitHub, GitHub sends a message to Code Climate and says, okay, I need you to go out and run all your QA tools and tell me if the code is good or bad and fail the build if not, so that way the developers know there's a problem. And then it makes the chiclet either red or green based on it passed or failed. So with Code Climate, it's if you have open repository, so an open source repository or a publicly available repository, Code Climate doesn't cost you a dime. You get all the benefits of this for free. However, if you have private repositories and you want to add them to Code Climate, then they do charge money for that. But the tool is good. It works really well. Basically, what it does is it gives you a GPA, grade point average, right? Just like you're back in school. You're trying to get an A or a B, right? And it gives you that grade point average. So for instance, a good GPA might be a 3.25 or above, whereas something like a 0.17, you failed pretty miserably. You need to fix that. So again, Code Climate is a good tool for that. It's pretty easy to set up. You log into Code Climate, you tell it what your repository is, and then you import it. It doesn't actually import the code, it just keeps track of it. And then from that moment forward, every time you do a commit or a push to origin in this case, because you're pushing to GitHub, then it knows it needs to go to Code Climate and have it rerun it and measure your code quality. Another useful tool is Zen Server. Anybody using Zen Server? Anybody heard of Z-Ray? Z-Ray is a new tool that we created in Zen Server. So what Z-Ray does, most of us, we probably, as we're writing code, we write code, we save it, and then what do? We go to the browser, refresh, see if it is working, right? That's the way I develop. So I spend a lot of time writing code, going to the browser, refresh, does it work? Write more code, go to the browser, refresh, does it work? As I'm doing that, all I'm doing is looking to see if the output is there, right? I'm not really getting good metrics on that. So where Z-Ray comes in is Z-Ray actually gives you back feedback and tells you if there's errors, if there's problem in real time. When you click refresh, it gives that to you right away in a toolbar. So you basically have this toolbar down along the bottom edge, and it's going to tell you all your errors and everything. And if you click on it, it unfolds to give you all this information. It'll tell you if there's errors in your code. It'll tell you the queries that are being run in order to generate that page. You can look at all your global variables that are available to look at, your server variables, everything else. If you're running certain frameworks and tools like Zen Framework or Symfony or Laravel or WordPress or Joomla or Drupal, we have extensions built into the toolbar that'll give you statistics on that tool, whatever tool it is. So it's nice to have everything compact. You don't have to jump through hoops and print R or eval or echo the information. It's right there in the toolbar, right at your fingertips when you click refresh. So it's pretty good to get that measurement right up front. And similar to that is Apache Bench. Everybody heard of Apache Bench? Apache Bench is awesome. So what Apache Bench is, it allows you to gain some sort of metric into how much traffic can my website handle, how much traffic can my web application handle, and based on what are the current statistics for my web application. So what we do is we call it, the command is AB, it's via command line. We tell it in this case, for 10 seconds, go to this URL over and over and over again for 10 seconds and give me back statistics on that. And what it does is it goes out and gains all those statistics, and then it'll come back and tell you, what the size of the page was, how many requests per second was it able to achieve. In this case, only 9.8 or 9.6 seconds per request. It completed 96 requests. The average time was 10 seconds, because remember we told it 10 seconds. And then we can see other information about the average time per request and so forth. So it supplies a lot of good information. Now, using this, we can very quickly extrapolate and say, okay, well, if I'm doing 9.6 seconds per request, if I'm going to throw 1,000 requests at that thing, it's going to be slow, right? We're going to have some issues. I'm going to need a lot of servers to host this thing. This was a monster. But anyways, it's good to know that information, and Apache Bench gives it to you really precisely. Another tool that I use, but I didn't create a slide on it yet, is JMeter. Anybody heard of JMeter? Yeah. JMeter is an awesome tool. It does kind of the same thing, only JMeter allows you to do some extra things like, you can kind of do the same thing with both, but you have to jump through hoops with Apache Bench, where JMeter kind of does some of it a little bit easier. But you can simulate logins and future pages and change your cookies and do kind of like proxying and things like that. But JMeter does kind of the same thing. It gives you an average request or average time per request and things like that. Great tool, JMeter. I hadn't used JMeter a lot until recently, so I need to go back and update my slides and include more information on that. But I encourage you to check it out if you haven't, and some really good usable information. So we've covered a lot. This is a lot of stuff to cover. It's impossible for me to go into much more detail than I have. I apologize for that, but it is only a 50-minute talk, right? 45, 50-minute talk. So we can only cover so much during that time frame. Please, I hope this provided you enough information that you're able to go out and continue experimenting on your own. Download these slides. The commands are very helpful, and there's a lot of good information out there. In conclusion, measure everything. As you're building your applications and you're getting ready to put them out there, measure everything. Know your application inside and out, and the only way to know that is by measuring. Don't fear the results. Share them. Let all the rest of the developers on the team, let the business know the results of the tests as well. If they don't know, they can't possibly give you the resources you need to fix them and tweak things and make things better. Oftentimes, if a business is a very time crunch type company, meaning they're always pushing faster, 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 oftentimes by sharing some of this information with them, it can highlight issues, and they're like, oh, okay, now I see why we need to slow down a little bit. This is why we have a lot of bugs in our application. So doing these measurements and sharing them openly can really help with that. Reduce the complexity of your applications as much as you can. Refactor, small little steps. Don't do big refactors, do small little refactors. They add up over time. Leave the code cleaner than you found it. Kind of like the Boy Scout motto, right? They always leave the campground cleaner than they found it. Same thing with the code. Always clean it up as you're going. Learn to smell problems inside your code. Learn the code smells. Go out and look. There's tons of resources on the internet to learn code smells and what they can help highlight within your code. Use refactorings to fix your shortcomings. Nice small refactors. If you don't know much about refactoring, I would encourage you, I have another slide deck out there called Refactoring 101. I gave that talk here a couple years ago. It's a very popular one. I'm also almost finished with the Refactoring 101 book that is based off of Martin Fowler's refactoring book, but it's PHP specific. Martin Fowler has actually given me help with that. He wrote his book in 2000, so it's time we have one for PHP. But that book is going to be a good resource. You can find that at refactoring101.com. Love iteration. As developers, no matter what our job is, in IT for that matter, iteration is how we do things, how we get better at things, and how we improve things. So I've put some resources on this last slide with some URLs to find some of these things. Please go out and rate my talk. And if you're interested, my blog is at geekyboy.com. I put some content out there. I have a lot on code quality, a lot on refactoring, a lot on clean application development. Please check it out and let me know how you found it. Thank you. Do you have a question?